Let's put into practice some of the basic ideas that we've developed and evaluate these logarithms without a calculator. We have log base 8 of 1/64, log base 4 of 2, and log base 1/2 of 4. The steps to be able to solve such a problem for each one of these will be quite similar. We'll set each one equal to y, which sometimes can be the hardest step, because if you don't set it equal to y, if you forget to do that step, then it's very difficult to do the next step, which is convert to exponential form. So let's start that with a. So log base 8 of 1/64 equals y. I'm going to convert that to exponential form. So 1/64, remember the exponent goes to the right-hand side, the y goes up, and so I have 8 to the y is equal to 1/64. So this is the exponential form of the statement. The other challenging part to these problems is you have to remember your properties of exponents. You have to ask yourself, 8 to what power is 1/64? Well, 8 to the second power is 64. And if you do 8 to a negative power, then that is 1 over 8 to the positive power. So 8 to the minus 2 would be 1 over 8 squared, which would be 1 over 64. And so this y would have to be -2. But as you can see in the original statement, y is exactly what we want to know, because y is the same thing as log base 8 of 1/64. So this is going to be equal to -2, and that would be my answer. Now, what about part B? Well, let's convert this to exponential form. So we would have 2 equals 4 to the y power. And now, in order to recognize which y would be correct for 2 to be equal to 4 to the y, you have to remember your fractional powers. Remember, if you have something like 4 to a fraction, that is going to be a root. So 4 to the 1/2, for example, would be the square root of 4, which would be 2. And so in this case, this y would have to be equal to 1/2. And so log base 4 of 2 would be 1/2. Now let's complete this last one. I think we can complete it in this space here. So we'll convert to exponential form. 4 equals 1/2 to the y power. And we'll use the same idea from part A. If you do 1/2 to, for example, the -3, this is the same thing as 2 to the 3 over 1 to the 3. And it looks like I lied when I said I could complete this in this space. So let's go on to a new page. So the reason why that is if you do 1/2 to the -3, that would give you 1 to the -3 over 2 to the -3. And moving denominators to numerators, that would be 2 cubed over 1 cubed, which would be 8. Now that's not the correct answer, but it gives you a little hint as to what to do for this exponential statement to figure out what y is. So the exponential statement was 4 equals 1/2 to the y. If you do 1/2 to the -2, then all of these 3's would become 2's. And you have 2 to the 2, which is 4. And so y is -2. And so that means that log base 1/2 of 4 is -2. So that's how we evaluate logarithms by hand. And it's a very important concept, because your ability to be able to evaluate logarithms by hand demonstrates that you understand what the logarithm is. However, that being said, if you take a, let's say, random logarithm, I don't know, log base 2 of 7, then this will be extremely difficult, if not impossible, to evaluate by hand, because if we were to try, we would write 7 is 2 to the y, and trying to come up with a y such that 7 is 2 to the y is extremely difficult. It turns out that this y will be an irrational number. And so if you needed to evaluate a logarithm like this in some applied science course, then you would likely need to resort to a calculator. But for problems such as ones given in this example, you should be able to evaluate these by hand without using a calculator.